You write a program to divide a number by 0, and when you run this program, the JVM throws an exception and your program gets terminated abruptly. But another Java programmer writes the same logic to divide the number by 0, and when his program is run, the program executes in a normal way. So you ask what the special thing that this programmer knows, or what he has done that his program is not getting the error thrown by JVM. Why JVM is being so partial? Well, the JVM is not partial, but the thing is, this programmer may be knowing something extra that you are going to learn in this video, and that's called exception handling. So in this program where you were trying to divide the number by 0, and when you execute this program, you are getting a exception in thread main java.lang arithmetic exception divide by 0. Now this is an exception that is thrown by JVM, and that's why your program is terminating in an abrupt manner. So before we begin all, you'll be interested in knowing what exactly these exceptions are, right? So let's dive into detail now. Before we start today's topic of discussion, I want to say that if you want to refresh or revise your any Java topics, or you want to start learning Java programming language, here is a playlist which is there on our channel, and you can see on any topic that you want to get a revision of, refresh the concept. Okay, so you can save this playlist and you can subscribe to the channel for further such videos. So let's get to the main topic of exception handling and what is exception handling. So let's go to the official Java documentation. So here we are at the official Java documentation, which is oracle.com, docs.oracle.com. Okay, I'll put this link in the description. You can go from here. So here the exception is defined. So what is an exception? The term exception is a shorthand for the phrase exceptional event. So some event which is exceptional. Let's see what this means. An exception is an event which occurs during the execution of a program that disrupts the normal flow of the program's instructions. Okay, so something that occurs while execution of a program that is not supposed to happen, or that is not correct. Okay, so these two things can be there, and that's why the exception happen, right? Exception occurs. Now you can read this all in detail, but a small part we'll see here. When an error occurs within a method, the method creates an object and hands it off to the runtime system, which is JVM. Okay, so here the runtime system is JVM, Java Virtual Machine. The object called an exception object contains information about the error, including its type and state of the program when the error occurred, and creating an exception object and handling it to the runtime system is called throwing an exception. What happened in this program is divide by 0. We all know that in mathematics it is forbidden. We don't have any answer to it. Infinite, you can say in mathematics we say, but in programming it is forbidden. It should be handled, and it is not supposed to happen. Okay, now when you do this, an exception error occurred here. This error will be as here the doc says, it is handed over to the runtime exception. So whole programming thing is going on, whole program is getting executed, and as soon as there is an error, there is a step which is not supposed to happen is there, then the runtime system gets hold of it. And since you don't know about exception handling, so you have not handled it, so JVM have checked that there is no syntax or any concept of exception handling in the program, so it is throwing you a exception which is known as java.lang.arithmetic exception, that is divide by 0. So this is what an exception is, and this is why the JVM is throwing an exception for your program. Now one more important point before we actually go and understand the exception handling, how to do the exception handling. The runtime system searches the call stack for a method that contains a block of code that can handle the exception. This block of code is called exception handler. Now what is this block of code and how we can write the block of code to handle the exception, we will see in this video. So here exception occurred and we were not able to handle it. In Java, there is a method, or you can say there is a syntax to handle this exception. Okay, so if you know that, okay, here we have hard coded the values, but maybe if you had taken the input from user, and if user has given this value, you don't know whether user will give the value of 0 or 1, -1, whatever it can give, right? It is the programmer's responsibility to ensure that correct values get added, but we can't control the user, but we can control our program. So here comes the concept of exception handling, right? So concept of exception handling in Java is being done through the syntax of try catch block. So try catch block is nothing like, you have seen the switch block, right? Switch statement, you create a switch block. You have seen if else block, right, to handle the conditional statements. Now here is the try catch block to handle the exceptions. Okay, so we write try, braces we write, and inside it we write the code in which we think that there can be a potential error if a wrong input is there. So we know that here if num2 is 0, this can be a error, right? If denominator is 0, then division by 0 can be a potential error. So since this block of code, we know that it is a part of it can throw an exception, so we just put this code inside the try block. And try block, you cannot write it standalone. It is mandatory that you have to write a catch block if you are writing a try block. So try block will always come first and catch block will always come after it and with it. Okay, so you write catch block. Then inside catch block, before you start the catch block, you have to write within the parenthesis what exception do you want to handle. Here we from the result we know that it is an arithmetic exception. Okay, but you don't know the name of the exception, right? So you can simply write exception E. So exception is a class. So exception is a class which is responsible for handling all kinds of exception. It is a generalized class. All the exceptions, that is arithmetic exception, IO exception, or various types of exceptions are part of it. So we can mention or are part of the hierarchy of exception. They extend it. So this catch block will handle the exception. Now how it will handle the exception? Either you can print the exception or you can print a particular message to the user in the console. So you can print the message to the user in the console that divide by 0 is invalid. So something like that you have provided. Now if you run this, your code is also, now no more JVM is throwing exception. Your code is handled. So as your code execution begin and the error line is encountered, it is handed over to runtime system. Now runtime system searches for the block which can handle the exception. Okay, so here there is a catch block which is able to handle the exception. That's why here your program is not getting your program is not throwing the exception, right? If suppose rather than exception, if you have written IO exception, okay, or maybe this index out of bound exception which we have seen in the arrays video, right? So if this index out of bound exception, if you write here, now if you run this program, it again throws the exception. Why it throws an exception? Because it cannot find a catch block which can handle the type of exception this error belongs to. This error belongs to arithmetic exception. So either you write an arithmetic exception here, okay, or you write the parent class of the arithmetic exception. Okay, so the parent class of all exception, all these specific types of exception is exception, right? It is more preferable that you specify a particular type of exception that you want to handle it. And suppose you have created an array. Suppose you create an array of numbers and I specify 4 numbers here. We have to put braces. Okay, so I create a array of size 4. Now if I access a number 4th index, now here the array's index start from 0. So it is 0, it is 1, it is 2, and it is 3. Now there is no 4th index. So if I am trying to print the 4th index, I am trying to access the 4th index, it will throw an index out of bound exception, right? So if I write this, it still not throws the exception. Why? Because by mentioning the parent class here, if you mention the parent class exception, it will handle all type of exception, right? You can say that it is a very good idea, but it is actually not a good idea because it doesn't actually tells you in specific that what type of exception was there that this catch block has handled. Okay, so here if you write a particular exception like arithmetic exception, here if you write a particular exception which is arithmetic exception for this line of code, then you will see that if you run the program again, here this line doesn't get reflected, right? Now your question may be, this line we have handled the exception for this, what about this? Why the JVM didn't throw the exception for this? Why? Because as soon as in the try block, if any line is found to have a error or a chance where the exception is to be thrown, okay, then after that line, all the lines in the try block will get ignored and the runtime system will search for the catch block, that if there exists any catch block which can handle this exception, and then it will execute all the lines of code that happens to be outside the try catch block. So this line of code was outside the try catch block, and that's why it was executed after handling the exception, right? So suppose here I mention 1. Okay, now if I run the code, I get an exception. So this line of code first executes, so I get 5 divided by 1 is 5, but this line of code will give exception which is index out of or array index out of bound exception. Now the exception is there, but we have not handled it. We have written arithmetic exception to handle this kind of exception. So to handle it, we can write another catch block, and here we can say array index out of bound exception e, and we can mention invalid index of array, right? Now if we try to run the program, you see the exception is handled and our program executes in a normal way. Now if there are multiple exceptions, then multiple catch blocks we can write, but this is a lot of boilerplate code, right? So many lines of code we have to write. So due to this, to make the code more concise and readable, there is a way in Java to do this, and what you can do is, after arithmetic exception, you can put this symbol or symbol, and you can then write array index out of bound exception, and then in the message you can write e dot get message. Okay, now if you just write custom way of writing, then again you will not be able to distinguish between it. So you can write e dot get message. This exception object will provide you the exact message, so you will get to know what type of exception you are getting. So if you run this program, see the message you will get index 4 out of bounds for length, right? So this is the way we can handle the exceptions, and specific types of exception can be handled in a combined way through this syntax in a single catch block. Now there in user input, if you see our playlist, we have discussed the user input scanner class. Okay, now scanner class is a type of resource. Okay, if you write scanner sc equal to new scanner system.in, then this is a type of a resource. Okay, right? And anything that in the Java is a resource needs to be closed first. So when you define this line of code, the resource get opened, but after that you have to define sc.close. Now this is the standard coding practices that is implemented in an industry, and it is mandatory. But what if there comes another exception which you have not handled? Suppose you have not written here, you have not handled here array index out of bound exception. Now if you write this code, your program will terminate abruptly, right? And due to which, what will happen, that the resource will not get closed. If the resource will not get closed, it means that the resource get leaked, and there is a chances of some abrupt behavior in your whole application, and there can be even security vulnerabilities due to it. So to ensure that the security vulnerability is avoided and all the resource get closed, in exception handling, there's another block known as finally. Now what this finally does is, irrespective of whether the exception is handled or irrespective of whether the exception is not handled, this finally block executes. So if I write sc.close here, in fact I will also write finally block executes. Okay, right now if I run the code, you just see that. So just see, this 5 get executed from this line of code. In this line of code we encounter an exception, but when the runtime when the JVM tries to find a catch block to if there is a catch block to handle this exception, it cannot find, so it will throw the exception as it has thrown. But we can see that this finally code block executed. Now after catch block, two things are written. After catch block, this finally block is there, and after catch block, this line of code is there, right? But only finally block gets executed. This line of code is not executed. This means that finally block will get executed irrespective of whether the exception is thrown, not thrown, handled, not handled. It doesn't care. It has to get executed. But again, this code is more verbose, right? We have to define another block, another lots of lines of code to write. First, we have to open the block here, and then we have to we have to remember that we have to put everything inside finally. So again, to make the life simpler, to make the programming more logical and better, there is an alternative to finally block, and which is within the try block, you can put parentheses and you can open here the code. Now you will say how this solves the problem. How this solves the problem is, you are just writing a code inside the try in the try parenthesis before the try block where the resource is being get opened. So whenever a code or whenever a resource is getting opened here, it is the responsibility of the JVM to close the resources, whether the exception is thrown or not. Okay, so you don't have to worry about it. And why the JVM will close? So the reason is, if you go here to this class, if you navigate to this scanner class, okay, if we navigate to the scanner class, then we will see that this scanner class implements the closable interface. It is a marker interface, and this closable interface extends the auto closable interface. And because of this auto closable interface, the JVM will automatically close the resource itself, whichever it is opened within the try parenthesis. Okay, this type of syntax is called as try with resources. Okay, so here you are trying with resources. So this is the resource, you are opening it, and during the execution of the program, whether the exception is thrown or not, it will be the resource which is opened has to be closed. It will be taken care of. Okay, so this is the one thing. This is all about try, catch, finally. Now let's try to delve a little more into the area of that there are two types of exceptions. One is checked exceptions and another is unchecked exceptions. So what are checked exceptions? Checked exceptions are those exceptions which we know beforehand. Okay, now here you are dividing the two numbers. So you know beforehand that two numbers division is okay, but if in the two numbers, in the denominator, if there is a 0, then that is an invalid operation. You know beforehand. You don't need the compiler or JVM to point that, right? So it is your responsibility as a programmer to handle that case. So we have handled this case. Similarly, there is a code to access the element of an array. Now you know that while accessing the element of the array, one should not access or one should not pass an index which doesn't exist in the array. So the index passed should be in the range between 0 and n-1, which is n here is length of the array, right? This we know that. So it is our responsibility that we handle this exception by putting array out of bound exception. So these types of exceptions in which we know that if we are performing certain logical operations, we know that, okay, there can be a possibility that due to this particular case or due to particular input or due to particular situation, this exception may arise, and therefore we should handle it. Such exceptions are called as checked exceptions. Okay, but there are some exceptions which is not in our control. Okay, so we'll go to Java docs to see those. Okay, so now let's see that. So here it says that the first kind of exception is the checked exception. These are the exceptional conditions that a well-written application should anticipate and recover from. So here we can anticipate that there can be a chance that num2 is 0 or the past index is not present in the array. So this is an anticipation, and therefore we are handling the exception. So where the anticipation is possible and we can handle it, those type of exceptions are called as checked exceptions. And here it says all exceptions are checked exceptions except for those indicated by error or runtime exception and their subclasses. So let's see what is an error. So second kind of exception is the error. Now error, what it says that these are exceptional conditions that are external to the application and that the application usually cannot anticipate. Okay, so those conditions due to which is external to the Java code. Okay, so it has given a very good example also, that suppose an application successfully opens a file input but is unable to read because hardware or system malfunction. Okay, suppose your hard drive gets corrupted or gets broken. Okay, so it is not the fault of your Java program which is trying to open the particular file present in that hard disk. It is the fault outside your Java application, right? So such things are called as error. So you cannot anticipate that. Okay, so therefore you cannot handle it. And the third kind of exception is the runtime exception. These are exceptional conditions that are internal to the application and that the application usually cannot anticipate. And most important thing, these usually indicate programming bugs such as logical errors or improper use of API. Okay, so runtime exception is nothing but though you cannot anticipate, but it is also the programming bugs, the logical error that you may have made, or the way you are writing your program is not correct, right? And the famous exception due to which this runtime exception is popular is null pointer exception. Okay, so sometimes if you are trying to operate something on the null, okay, so let me give you an example, or let's write here only. Suppose you write string str equal to null. You are assigning str, the string reference as null, and you say sout is equal to str.length. Okay, now if I run the program, it gives me java.lang.null pointer exception. Now this here you can anticipate because we have hard coded the values. But suppose your string value is coming from, suppose, the user input from the UI. Okay, there is a front-end application that is taking the input for you, sending input data to the backend. And suppose you have not put the validation in the form filling, suppose, and there is a form field which requires the value, which is expecting a value, but its value is being left empty. So when it passes to Java will treat that value as null, and as soon as that null is passed and something is operated on it, a null pointer exception will be thrown. So this you cannot anticipate that, but you can still, once this exception throws, you can now you can handle it, and you can now apply the validation that before operating string.length we need to check. So you need to handle this case. How you will handle this case of null? You will write an if block which will say if str equal to null, then you will print invalid, else you will print string.length. Okay, in this case if you run the program, you see your program will not terminate abruptly. It will execute in a normal manner. So these are the programming bugs that you encounter. Okay, and it happens due to mostly because there is some bug in your program. So this is all about the fundamentals of the exception handling. You can read for the further document to understand more, and this covers the fundamental about the exception handling part. Now in the next video we will explore more in detail about the exception handling and how can we create our own exceptions, because there are some exceptions which we want to create for ourselves, right? We cannot always need the exceptions which are always present or given by the Java programming language. So we will see that, and we will see how we can handle those, create those, handle those using those exception classes. Okay, that's it for this video. If you like this video, please click on the like button and subscribe to the channel for further new videos. Till then, bye bye.